Okay, day 2. Proving triangles congruent using SSS and SAS. So the side-side-side postulate says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So, example 1. Are they congruent by SSS? If so, write a congruent statement. So, again, you want to look at go ahead before you do anything else. Mark this, please. It was supposed to be marked, but it wasn't. So, we can see that this side matches this side, this one matches this one matches this one. So we have 3 sides marked congruent. Now we just got to figure out the order of the letters. Remember we talked about orders very important. So DOG. Now the way I kind of say is you're starting at D and you're going to O. So what I say is use numbers for these. 1, 2, 3. 1, 2, 3. And you're starting at D and you're going down Highway 2 towards the corner of 2 and 3. So if you're trying to figure out where to start, do I start at T or C? Well, if I start at T, I'm going down towards Highway 3 intersection. If I went this way, I'd end up at 1 and 2, and that's not what I want. So that means I'm going to do T, C, A. So triangle T, C, A. Okay, was right here. Okay, we have these 2 the same and these 2 the same. Well, this one is the same because it's itself. So WS is equal to itself. Because I could separate this. If I cut this down the middle and pulled them apart, obviously those 2 lines would be the same because they were the same line. I just cut down the middle. So you know these are going to be equal. So once again, we just start. We went from here down here. So we traveled on Highway 1. So we're trying to travel down Highway 1 this way to WH. And where does that leave? S. Now, letters don't matter here because I only have one side marked. I know nothing about the other 2. So the answer is we don't know. We're not saying they're not congruent. We just don't know. We can't prove it based on the information given. Example 2. Is there enough information to conclude the angles are congruent? Those are the same. These are the same. These are not marked. And right now, based on the information we know at this point in the class, we cannot assume those to be equal. So we say, no, we don't have enough information. Okay? Here we have 1 and 1 hash mark. Here we have 4 inches and 4 inches, so that's the same. We can even put hash marks on there. And as we just talked about, OC is congruent to itself. So ROC. We start up at R and we go down to Highway 1 to O. So we're going to start at K and go down Highway 1 towards O. So ROC is going to be KOC. Congruent. Okay, included angle. The included angle is the angle between 2 sides of a triangle. So for sides AP and XP, so here's AP right here, here's XP right here. What is the included angle? Well, it's the letter. Well, if I could draw it correctly, sorry. Here's XP. Not good with my letters apparently today. But I noticed that from saying, coming back here and saying it's the letter they have in common. They both meet at P. That means angle P is the included angle between those sides. It's the angle formed. So we could also say the angle formed by two sides. You can look at it either way. Okay? For AP and AX, you don't even need a picture. You know it's going to be the one, and that's the one I started to do incorrectly before. Here's AP, here's AX, where they share, right there. Now, which two sides will make X be the included angle? Well, we need this. So, basically, that line goes there, and that line goes there. X is formed by AX and PX. Side, angle, side. If two sides and the included angle, the one in between them, of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So, are they congruent by SAS? Well, we have one hash mark here, we have the two hash mark there, and this angle here is in between them. It's formed by this line and this line, and this angle is formed by these two lines. So yes, we do have enough for SAS. But we need to follow the order. So T, going down Highway 1, and then Highway 2. So we're going to start at O and go down Highway 1 and go down Highway 2. So that's going to be OXF. And we actually say by SAS. Let's go back to the first page. I don't think. Yeah, we should say by SSS here and by SSS here. You prove that is congruent statement. So you gotta be sure to do that. I apologize. Okay. So we have this side is congruent to itself, and we have this side marked and this side marked. Well, this angle here is not in between two sides. We would need RE to make it the included angle. Notice if I call this RL and EL, do they have a common letter of R? No, they do not. And over here on the left side, I would need U. Well, I have LU, but I also have RL. Again, I don't have U in both of them. So this is no. Can't prove it this way. Over here, 1 mark, 2 mark, and the right angle is not an arc mark, but we know they're both 90 degrees. So therefore, this is the included angle formed by these two sides. So, SUN. We go on Highway 1 to the right angle. So we go down Highway 1 to the right angle over here. And there we go. Are they congruent? Now here's where we got to pay very close attention. And which postulate? So we have a 1 and a 1. We have a 2 and a 2. And all we have right now is this mark and this mark, which says parallel lines. So at first we think, well, we don't have enough information. But think about last unit. Two lines intersect to form vertical angles, don't they? And vertical angles are equal. Therefore, we know both angles at U are the same. They're congruent. So we do have a statement. Now here's where we got to be careful. HOU. So we're starting at H, and we're going down coming back down Highway 1. So if we started at S and went this way, we'd have to go down Highway 2, and that's wrong. Sorry, we're acting weird. So if we want to go down Highway 1, we're going to start at E, go down Highway 1 this way. So HOU is going to be congruent to FSU by side, angle, side. Okay, on B, 1, 1, 2, 2, equal to itself. So obviously congruent. It's going to be congruent by SSS. Now we have to look at the letters. B, E, U. Highway 1, then Highway 2. Highway 1, Highway 2. B, L, U. Okay, well, we have vertical angles here. And we have those sides are equal. And that's all we have. So we don't have enough information. They may be congruent, we just can't prove it right now. Okay, pictures help on this. So we have JK, just draw a triangle, JK, draw another triangle, is congruent to WI, and mark it. And then JO, so that's going to be O over here, and WN are going to be congruent. And then it says angle J is congruent to angle W. So we do have an included angle, so we can just pick a letter. I'm going to start at J. Triangle J, O, K is congruent. Now, once again, I'm starting at the included angle on this one. So I'm going to start here. And I travel down Highway 2, so I'm going to travel down Highway 2 here, W and I. Oh, triangle. And we say by SAS. B, I'm going to come down here and C, I'll do down here. So, quick triangle, doesn't have to be beautiful. MD is congruent to IN. Then we have ED, so that means this is an E, is congruent to AN, so that's an A. So we have MD and IN, ED and AN, and angle D is congruent to angle N. Again, we have the included angle. So, we have SAS. So I'm going to say triangle, I'm going to start at my included angle again. You don't have to, it's just an easy mark. I'm going to triangle down Highway 2 this time. DEM is congruent to triangle. I'm going to start at my included angle right here. I'm going to travel down Highway 2, so that's NAI. I say by SAS. Notice here I have no angles mentioned, so therefore I'm not going to be using SAS. So let's see if we have SSS. GE is congruent to MT. EO is congruent to TR. And GO is congruent to MR. Therefore, I'm going to start where I want. I'm going to start at E. And I'm going to go down Highway 1 or up Highway 1. GO. Ego. Triangle ego is congruent to triangle T. That's an A. T, M, R, by SSS.